Hi everyone. Sorry for that brief, I don't know, brief testing screen. I was trying to figure out the permanent URLs for streams, and I think I may have figured it out. I have a message in our Slack channel asking, to try this link out and let me know if it's not working. So I might, there might be a little bit of clumsiness somewhere here in a few minutes. Let's see. I think there's a lot of latency also, but maybe that's okay. Yeah. Okay. All right. Yeah, so what I'm going to do today is I'm gonna kind of I've been going, I don't know, not deep, but going into dictionaries to kind of solve a lot of or to do an analysis on different functions or different phenomena, anything that kind of seems interesting to me at the moment. Maybe what I'll do is this. Today I'm going to kind of dial it back just a little bit with the dictionaries and do some really easy stuff. How about that? And maybe expand on those easy things a little bit. I've been noticing some people struggle with some, like in our interviews, some people struggle with dictionary manipulation when presented with different types of problems. And I'm going to maybe just create some different ideas of problems, like really abstracted. Also, I'm going to answer questions that y'all have. So why don't I pull up this initial question, and then I'll switch gears over to dictionaries. Okay. So we have this unit called while loops and open-ended problems. So in general, I encourage avoiding while loops in general. And when we think about open-ended problems, we're thinking about things where we might not know the number of iterations we're planning on performing, and for that reason, we would just use a while loop. Offhand, I'm just going to show you a quick kind of maybe quick trick, right? So we've got a while, and I'll say while true. Let's print this is running, and maybe I just maybe I'll do something like this. I'll say input gets, oops, not input gets, but INP gets input. And this is just going to say keep going. And if int equals y, then, sorry, let's say not equals y, then let's break the loop. Okay, so this is pretty boneheaded, but I'm just going to put this in as an initial just thing to think about. Okay, so here's dummy.py. This is running. Keep going. Yeah, sure. Yeah, why not? Yeah, great. And we'll do that for a little bit, and then I'll hit Q. I could have hit anything, and it would break out. So I'm going to do something equivalent to this, or reasonably equivalent, that with Python, often this is actually what I would do. And the reason I would do this is it seems, you can time it, you can use time it, and this tends to run faster. For loops tend to run faster, and they you don't ever run the danger of having an infinite loop. So what I might do here is for however many times in the range of something reasonable, or maybe something unreasonable, right? That many times, that's a lot of times, but let's say 100,000 times. I'm just going to take all of this and copy it directly. But I just want to show that this is equivalent logic for our purposes. Now, you might have something that is a wait state or a runtime, and like in those cases, while loops are preferred, right? Where the while is just encapsulating everything. But if you are dealing with programs that are like that, often you're not going to use a while loop for that. You're going to have some sort of actual runtime environment that under the hood is a while loop, but it's not a Python while loop. So here is for whatever in range, 100,000 times. This is running, input, keep going. I'll just demonstrate this really quick. Yes, 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 yes. And of course, no, and that breaks out. In all likelihood, we're never going to run this while loop 100,000 times. And so these two forms of logic end up being equivalent. But this logic on line 12, using a for loop, at least it grants you avoidance of an infinite while. Not that that's the end of the world. You can always break your program. Control C or Control Z in the terminal. But yeah, anyway, that's just a quick statement on while loops. We present while loops because they are so common, and you'll be expected to understand why to use them, when to use them. So let's just look at the third challenge here, which it looks like I had solved at some point. Let me just reset the input on this. 1 second. Okay. So this is a twin prime function. I find this to be a super interesting. I like prime numbers, so maybe I just find this interesting because of primes. The twin prime conjecture is a theory in which there are an infinite number of pairs of primes that differ by 2. This function, twin prime, finds the nth twin prime pair. So, for example, the 5th twin prime pair is 2931. Yeah, I might actually record this because this is I think the third time a question has been asked on this problem, which is great. I think it's a great problem. I think I'm gonna just record my video here because then I can embed this video once I finish streaming, and then we'll have a solution video up here for this. In the long term, we do want to have solution videos up for everything, so that yeah, just so you have them. Okay, so 1 sec. Let me start recording. All right, so we're looking at this twin primes problem in while loops, and we've got this statement: the twin prime conjecture is a theory in which there are an infinite number of pairs of primes that differ by 2. So we're considering 5 and 7. Those are twin primes. 3 and 5. The 5th twin prime pair is 29 and 31, right? So what we're looking for here is writing a function that finds the nth twin prime pair. The first twin prime pair would be 2 and 3. Sorry, 3 and 5. The second twin prime pair would be 5 and 7. And, you know, apparently the fifth is 29, 31. So what do we need to solve this function? We're going to need a few things. One thing we want to figure out is, well, how do we determine if a number is prime? Well, you know, we can do that pretty easily. We can say, we can write a function called isPrime, right? And isPrime is going to take some number. And we can say if the number is less than 2 or the modulus of that number by 2 is 0, then we know it's not prime. Right? 1 is not considered a prime number. Negative numbers are not considered prime. And we just cover those cases when we do that. All right, so if the number is 2, then we can return true. 2 is a prime number, but it's also, well, I just like covering the space. I think logically it's kind of nice. And then I can say for divisor in range, and we'll start at 3, right? We've already covered even numbers. And we can go up to, well, let's say we can go up to the number, right? So we're going to start at 3, then 5, then 7. We can check all the odd numbers starting from 3 up until, but of course not including the number. And if the number is evenly divisible by the divisor, then we can return false. Otherwise, we can return true. So let's check this. So let's print is prime of, let's do 29. And that should return true. Let me make sure that this is not going to fail. I'll just put a pass in here. All right. So I'm going to run Python. So true. Our isPrime of 29 is true. And I'm just going to improve this slightly. I'm going to say that the number, let's see, the square root of this number plus 1. So I believe this is just a subtle optimization. Is that how we want to do that? Yeah, I think that should work. Oh. There we go. Oh, that's a float. I'm going to convert that to an integer. And that just reduces the number space for us. So let's test that with some other numbers. Let's test it with 27. 27 is not prime. Let's do 121. 121 is also not prime. So why don't I do this? I think this is kind of a nice way to do this. If you really want to visually check this, you know, we can say for num in range, and let's do 2 to 2000, and let's say if is prime of num. If that number is prime, let's print it. And this will get us better verification, right? And 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43. This looks like a good list of prime numbers to me. Okay, so spent a little time on that, but it's important to verify that your function is working as expected. Okay, so when we're thinking about prime pairs, we're thinking about a prime and the next prime. So I'm going to write a function called next prime. And this is just going to get us the next prime number. So the next prime of the number, I'm going to say the number to check. I'm going to start checking at num plus 1, right? So the next number, literally the next number. So if I put in 2, the next number I'm going to check is 3. And I'm going to say while is prime, okay, of the number to check, as long as that number is false, so here I'm using a while loop, then I'm going to say number to check is going to get incremented by 1. Okay. I could optimize this slightly. I could make it so that there's a little bit of logic to account for evens, because we should never really need to check evens. And I could do something like that with a for loop. I would more likely use a for loop in this case, but you know, I would have to write some logic to determine a reasonable max number of steps away from the current number, right? Like, can we confidently say that out of the infinite spaces for primes that we're never going to encounter greater than 100,000 values between one prime and another prime? I'm not sure. I actually have a video on windows of primes if to analyze that sort of thing. But in general, we could use a for loop, and I would probably just put 500 in there. I doubt we're going to exceed 500 anytime soon. Okay, just to be eyeballing it. Okay, so let's return the number to check, right? And let's test this. So if I put in, I'm going to say for num in range, let's just do 100. I think that's fine. We're going to print the next prime of that number. And so if we throw 0 in here, we would expect to see 2. And let's just find out if that's what happens. Because we're starting at 0 and we're ending at 99. So let's see if the logic here is sound. Oh, we actually skip 2. Why do we skip 2 if num is 2? We start at 1. And while is prime of the number to check is false. Huh. Oh, I see. I see why this wouldn't work for 2. I'm just going to throw just a snippet of logic in here to get around it. So if num is 2, let's just return 3. Let's see if that gets us around it. It doesn't. Oh, of course it doesn't. So let's say if num to check is 2, let's return 3. Let's find out if that gives us a 2 at the beginning. Interesting. Okay, well, num to check, num plus 1. So if we're putting in 0, then the first number we check is 1. And if num to check is 2, we return 3. But it's not, so while is prime, num to check of 1 should be false. When we increment it to 2, is prime of 2 should be true. If num is 2, return true. Let me just double check. Is prime of 2. Make sure I'm not missing something here. I'm getting a false for is prime of 2. So if num is 2, I should return... Yep. I should have just tested this a little bit more. I was checking 2 is obviously divisible by 2. That's why I was returning false here. Silly logical error. Corrected it. Now I'm getting is prime of 2 is true. Okay. Anyway, let's look at this next prime. And let's look at this. So 2, 3, 3, 5, 5, 7, 7, 11, 11. So we're essentially getting only prime numbers out of this, which is what we'd expect. So we're checking the next prime for every number between 0 and 100, and this works generally. We don't have to put a prime in for next prime. We don't have to say next prime of some prime number. in order to get the next prime. We can put any number in there and get the next prime. So now we've got the tools that we need, or two tools that we can use to find the nth pair of twin primes. All right, so let's write another function, just a quick one. Let's check if a number is a twin prime, right? Let's say is twin prime, and this is going to be num1 and num2, okay? And if num2 minus num1 equals 2, right? That's our twin prime. Then we can return true. Otherwise, we return false. Now, I'm actually going to invert this a little bit. Well, I'm going to add just another qualifier in here. If num1, if is prime, right? If is prime of num1, or if that's true, or if is, I'm sorry, is false, or is prime of num2 is false, then we can return false. Now, this is a little bit of redundant checking, but you know, we don't want to, at some point if we accidentally throw in, say, 7 and 9, if we only had this logic between 27 and 29, num2 minus num1, right? 9 minus 7 is 2, but 9 is not a prime number. So I'm just trying to be honest with my function definition here, is twin prime. I just want to be honest with what this function is doing. Okay, so let's go ahead and write this twin prime function. We're trying to get the a value out of this that is a pair, right? We're returning the nth pair of twin primes in the form of a list, right? And we want to input the value n, right? So if we put in 5, we should expect to get 29, 31 in a list. Okay. So I'm just going to do this in a fairly straightforward way to try to make it simple enough to understand. In case, just so, you know, because there are very clean ways to do this, I'm going to make it just a little bit messy, but I think it'll be understandable. So we have a twin prime counter, and then we have a number to check, right? And we're going to start this at 2, okay? And if the nth, right, that nth number, like if it's the 5th number, the 4th, or the 3rd, if this is 1, if we're looking for the first twin primes, let's just return our first twin primes, which are 3 and 5. So that just, this makes it a little bit easier to write this function. We just get sort of the first value out of the way. And then I'm going to write a while loop, although I don't necessarily need to. I'm going to write a while loop here that is going to be, well, let's say our next prime value is going to be the next prime from our number to check, right? So number to check is, yeah, so we're going to essentially get the next prime from where we are. All right, and if is twin prime of the number to check and the next prime value, then our twin prime counter, right, our nth number, is going to be incremented by 1. And we can say if the twin prime counter is equal to the nth value, right, because that's what we're looking for, then we can just return this list. I would normally do this as a tuple, but it's asking for a list. So this is going to be number to check and the next prime value. And then I just need to increment, sorry, I need to take the number to check, right, and replace it with the next prime value. notice we're not checking every number. We're only checking primes against their next primes. We're not making a sort of counter that checks 4 and 16 and all of these numbers. Okay, so let's test this out. We know that for the 5th prime, we're supposed to get. Well, I erased the doc string. We're supposed to get 29 and 31, I believe. So let's see if that's actually what we get. We do. We get 29 and 31. So I'm going to just write one more thing. This is kind of a fun thing that you can do, right? So let's say for I in range, let's look at the first 100 twin primes. Let's just print the twin prime of I. Oh, I may have asked this to do something that is a bit extreme. I think let me kill that, and let's dial this back to let's dial it back to 10. Just look at the first 10 twin primes. Oh. Do I have an infinite loop here? I don't think I do. Let's look at the first 6, because maybe maybe the next twin primes are just really far up there, or maybe I do have an infinite loop. Huh. Believe my logic here is sound. Oh, okay. We're starting at 0. So that's a little bit nonsensical, I think. There we go. It was just that I was starting my range at 0. Let's try up to 20 and see what that gets us. Excellent. Okay. So let me just do something. Let me resize my window and run that again. So here are our first 19 twin primes. So let's try this. Let's try this out. I'm going to copy all this code, and let's see if it passes our tests. I suspect it will. Yeah, and that did. Really quick, let me just snag this other code, the solution, the example solution that's in there, and let's look at it. Let's look at it. It's going to be a little bit different, of course. So here's our twin prime. It's going to use a next prime function that, if you look at this, our next prime function is just a couple things. We already have that logic, but we spread it across a couple more functions, right? And this check twin primes is twin prime function that we wrote up here is encompassed in this logic on line 81. But at the end of the day, this is basically doing the same thing. It's using a prime 1 and prime 2. I think what we did up here was, what was it? It was next prime val and number to check. So yeah, hope that's helpful. Let me know if you have any questions on that. Is anybody having trouble hearing me? If you can hear me, or if you can't hear me, if you can't hear me, do something. If you can hear me, give me a thumbs up in the Slack thread really quick. I noticed somebody mentioned that they're not getting any sound. Okay, okay. Maybe, huh, okay. Was the sound out, or was it an error on your end? I just want to make sure that I'm not having some issues here. I've been having sound issues for a bit, so with this interface I have. But okay. Okay, I'm gonna go on to the next question. I kind of want to come back to these primes problems. I really like them, and we can find a way to analyze them through dictionaries. So I might just leave this up here and return to it in a bit. Okay, so there's a question. There's a question on, let's see. I've been struggling with the third question on traversing a single nested list. Okay, so let's look at that. Traversing a single nested list. And okay. Yeah, let's take a look at this. It's I believe challenge 3. Is that where it is? Question 3. No. Let me double check that. Yeah, third question. Traversing a single nested list. Or traversing a list challenge? Okay, yep, the third challenge here. See, in the code cell below, write a for loop that will add the corresponding values of list 1, list 2, and list 3 together and store them in the corresponding position in a list called output list. Okay. Yeah, let's do this. So I'll just make some space here. All right, so we're working on traversing a list challenge 3. In the code cell below, write a for loop that will add the corresponding values of list 1, list 2, and list 3 together and store them in the corresponding position in a list called output list. So list 1, list 2, list 3, and we should get some result that looks like this. So we're not writing a function here, just so you can see that. We're just taking each of these values and we want to end up with a result that looks like this. So what should we name that? Let's call it, it says we should call this output list. And there's a couple ways we could do this. There's a couple ways we could do this. And I'll go ahead and do this. I'll start off in a very simple way. We could say list 1 sub 0 plus list 2 sub 0 plus list 3 sub 0. Right? I just want to be, I just want to show you a way that's a little bit more time consuming, but will get you there. And then I'll show you a way, I'll show you a better way that is more in line with what this problem, what this challenge is really about. Okay, so I'm making a list of, oops, this should be, I should be changing the list names here and not the list indices. Okay, and that should be 0. And then I'll just copy all this again because that makes sense to do. It kind of sounds like maybe there were some sound issues that happened. Let me know, please, if that persists in any way. Okay, so list 1 sub 1, list 2 sub 1, list 3 sub 1, and then list 1 sub 2, list 2 sub 2, and list 3 sub 2. So I'll just print the output and let's check it against what we expect to get as output. Okay. So 4, 9, 14, that's what we expect. That's one way to do this. and I suspect that this would work for passing this challenge. However, since we're thinking about traversing a list, why don't we write a for loop to do this instead? So I'm going to say for I in range of the length of list 1. I'm going to have this output out here, so I'm going to have an output list that's empty, and I'm going to say output list list.append, and I'm going to put in here the value resulting from one of these operations. And instead of sub 0, I'm going to do sub I, sub I, sub I. And this should get us the same result. And it does. So yeah, hopefully that clears up this challenge. We can do this manually, right? Because it's a relatively short list. Or we can do it procedurally using a for loop. I recommend doing it procedurally, right? It's just simpler that way. All right. So, yeah, I hope there aren't any persisting sound issues. That's a little troubling. But because everything on my end seems to be working fine. So I don't know. Okay, so back to these is primes. Why don't we think of a way to approach these? Like we're considering twin primes right now. What could we do to analyze these? Maybe when we're looking at this, we want to consider the numeric, the number here as a key. So why don't we do that? Why don't we build a dictionary where yeah, let's just build a dictionary really quick and kind of take a look at this. This is not so different from what we just did. So in this dictionary, let's call this twin primes dictionary, and let's do a low n to a high n, and we create this dictionary. I'm actually gonna do dict. I like doing that more. That's to me it looks a little better, and it's easier to see that it's not a set. I'm going to say for n in range, I'm going to go from the low n to the high n. In this case, I'm going to do high n plus 1. This is a thing I notice many of you do. You tend to put a plus 1 on every range. That's often not going to be true. In this case, we're doing a low n to a high n because we actually care about the value of n. And we want to be inclusive of the high n because kind of the implication of having high n in here as a parameter is that we want to know what the value will be for that. So I'm going to say d sub n, right, is just going to get the twin prime. So let's think about that. The twin prime of n, well, we can just call this, right? We can just get the twin prime of n. And we can return the dictionary. So that's fairly easy. Let's say for key value in d.items, we're going to print the key and the value. Of course, I have to call out to twin primes to get that key and value. And I'm going to just start at a value of 1. Yeah, I started at a value of 1, and I'm going to go up to the 100th prime. and let's see how that does. And we should get kind of a nice representation of this here. Okay. So notice we've got all of these values, and now I have this curiosity, and I don't know. You know, this is the kind of question that you can ask yourself and then write code to answer. I'm going to ask a question like this. What is, and let me think of what is, how do I say this? Is the growth of the, is the growth of the divisibility of the sum of the twin primes by the nth positional value, I don't know. Is this linear? Is this reasonably linear? This is one of those questions that you can answer, as it turns out. So all that I mean here is that we can sum, right? We can sum, you know, prime 1 and prime 2. And I'm going to divide that. I was thinking I could floor divide it. Why not? Let's floor divide it. And let's floor divide it by the value of n. Okay? And see where that lands us in this dictionary. So I'm going to write a function. Let's call this twin primes sum divisibility, sum division. How about that? Def twin primes sum division, and we're going to go from a low n to a high n. Why not? And we're going to for each of these we're going to get the twin primes, right? So I could just call out to the twin primes dictionary, and why don't I do that? I'll just get that. And instead of starting off with a dictionary that is empty, I'm going to start off with this twin primes dictionary. And I'm going to say for key value in d.items, all right? I'm going to say, well, I can just do this. I can say, I'm going to change key to n, because that's what our keys are. That's the positional value. So I'm going to change that to n. And v, we know v to be a list. And I'm just going to use it as such. I'm going to say prime 1 and prime 2 are going to get v, right? So we're just going to unpack v into prime 1 and prime 2. And now what we can do is, we didn't really need to unpack those, to be honest. We could have just done sum of v here. That would have been fine. We could have just done that. That gets us the same thing. But I'm just going to be explicit about what I'm doing here. And I'm going to say d sub n is going to get the this division, this floor division value. And let's see what that looks like. I don't know what this looks like. And this is a thing I want to encourage you to experiment, to ask yourself even ridiculous questions. You know, like how is this helpful to anybody? I don't know. I'm sure somebody at some point asked themselves this question, and it's possible that this is reasonably linear, or maybe it's not. I don't know. So let's go with I'm just going to copy this snippet and I'm going to comment it out. I'm reusing the name D. Why not? And this time I'm still going to go from 1 to 100. And let's just print this out and see what we get. Okay. Now, so this is interesting. The first twin prime, right? If we think about what that was 3 and 5. 3 and 5 plus 8. Sorry, 3 plus 5 is 8 divided by 1 is 8. And then 5 plus 7 is 12 divided by 2 is 6. So we go 8, 6, 8, 9, 12, 14, 17, 18, 22, 21. So we get a little bit of oscillation here. Maybe this doesn't behave the way... Maybe this doesn't behave linearly or reasonably linearly, you know? Like, do we have a consistent rate of change here? I don't think we do necessarily. But we can see that it's growing. And that's kind of cool. So we can see that it's growing. Since we're floor dividing, we could look at this in a different way. We could do it not as the sum. We could do it as just a single one of these numbers divided by n, right? Because that's roughly where these are at. Yeah. We could also get rid of this floor division and do regular division and see what we get. And we can kind of see that there are a couple instances where here where we have evenly divisible positions. So we could even ask the question, we could take this a bit further, right? We could ask a question like this. And this is just nature of exploration, experimentation. Let's say in what cases, how about this? Which twin primes, when summed, can be evenly divided by their positional value, right? So in other words, can be evenly divided by their positional value. So in other words, can the fifth twin prime pair, right? This is what was that? Was it 39 and 41? Oh, I don't remember. We can find out really quick. In fact, let me do that. Let me just print the twin prime of 5, I think is what that would be, right? Twin prime of 5. 29 and 31. Okay, so 29 and 31, when summed to, that's 30, 60. When summed to 60, be evenly divided by 5. Okay. And of course it can, right? So, why is that? Why is that? Let's not worry so much about why. Let's just discover the twin prime pairs that can be evenly divided by their positions. Okay, so I'm going to say, how do I want to do this? Let's do it like this. And I'm going to just call this function twin, what should I call these? Twin primes. I'll call this twin primes mod position. And we'll go from a low n to a high n. And one of the questions, I can do this in a couple ways. I'm making a dictionary. I could, well, I'm still going to get this twin primes dictionary. I think that's fine. What do I want to return here? You know, that's kind of the question. Do I want to return a dictionary? And if I return a dictionary, what will be the values in that dictionary? What will be the keys? If I return something else, do I just want to return a list of the tuples, or a list of lists of the twin primes? Right? I could do that. I think for this, I'm going to make another dictionary, and I'm going to call it dout, and I'm going to say I'm going to call this, I'm going to make two keys. Mod position is true, and I'm going to make this a list, and I'm going to make another one called mod position is false, and that'll be another list. Yeah. So let's do that. And I've got prime 1 and prime 2, sum of prime 1 comma prime 2 divided by n, right? This is our, we can modify this just slightly. We can say modulo n is 0, okay? So what do we want? What do we want here? What do we want to put into n? Do we want only this? I actually think we want a little bit more than this. I'm gonna say if this is the sum, then I want to append to dout sub mod position true. I want to append to this something, and maybe what I want to append to this is a tuple. I'm just going to throw a tuple in here. Why not? And there will be a tuple within this tuple called prime 1, prime 2, and then the third value in the tuple is going to be n. So it's sort of like saying, well, here the sum of these is going to be divisible by n. And maybe I even will attach the sum, because part of what I care about here is whether or not like I'm taking an analytic approach, and I'm kind of digging for a signal, you know? When these are evenly divisible, what explains that? And it doesn't have to be some magical thing, right? It doesn't have to be, you know, that we're going to discover some new property of numbers that that no one's ever thought of. Probably not. It's probably going to be a really simple explanation for the reason why these are evenly divisible. But, you know, hopefully this will bring us to an epiphany, and maybe it won't, but I think it probably will. So I'm going to get this dictionary out. This dictionary has two keys, and we're going to take a look at these results. So I'm going to get this out like that, and I'm going to do more numbers here. I'm going to go from 1 to 1,000. And maybe what I'll do here for kv in d.items, I'm going to iterate over the values instead. So I'm going to print the key, and then I'm also going to say for val in v, I'm going to remember this is a tuple, right? So let me just take a look at how that tuple looks. Because I want to kind of be able to look at this in a way where I find it readable and understandable. All right. So that's what our tuple looks like, and the first part of the tuple is here. This is sub 0, right? And this is sub 1. Sorry, this whole thing is sub 1. This is sub 2. So I'm going to say, let's go ahead and print, and maybe I'll tab this in. I'll just do something like this. I'll make this an F string, and I will say v. Oops. So it's going to be v sub. I'm going to do v sub 1 for the sum. No. I'm going to do v sub 2 for the num. And I'll do v sub 2. Sorry, v sub 1. And then maybe underneath this, I'll do 2 tabs. And here we'll look at, how about not a minus sign? Let's do that is evenly divisible by that. Yeah, that's fine. So v sub 2, we don't need v sub 2, we just need v sub 0 at this point. And this, remember, is our tuple pair. Yeah, why not? Why not? You know? Or maybe I'll switch the sums around. I'll switch the sums around, and I'll just throw a modulo symbol in there. Why not? Let me speed this up a little bit. Okay. There we go. So let's see what we get out of this. Let's see if this is interesting. Let's see if this is computationally intractable, apparently. What did I do before? I did 1 to 100. I think we might be searching really heavily. Let me kill this and make sure that I'm not, that I don't have an error somewhere that's actually getting me hung up. Oh, here we go. List index out of range. I thought I had 3 values here. So v twin primes mod position 1 to 100, 1, 2, so 0, 1, 2. Am I missing something here? Let me break this down. Every once in a while, yeah, let's break this down, make sure I'm not misthinking this. Okay, so here's sub 0, right? That's our prime 1, prime 2. Here is the sum of prime 1 and prime 2. Let's just print v and find out, because let's just print this val. Oh, I see what I'm doing here. I don't need this internal loop. Or do I? No, I do. I don't want v sub 1 sub 2. I want val sub 1 sub 2 and val sub 0. Okay, let's try that. Name prime 1 is not defined. Obviously not defined because that was copied from the function. Okay, int object is not subscriptable. Oh. Okay, let me just take a look at V here, because I might be, I might have some other error. And this is normal, just so you know. I'm returning the wrong dictionary, right? Notice I'm returning my twin primes. I don't actually want the twin primes. I want the differences here. Yeah, perfect. Okay, so I don't want to print that. And I do want this internal loop. So let's see if this is readable. Oh, I didn't put an else in here. Why don't I do that? Let's say else. And we'll say dout mod position false, right? These are all the positions where the sum of the primes was not divisible by the positional value. Okay, so let's try that again. And I think we're doing this for 100 values. Let's do it for 1,000 and see if there's any particular lag with that. That might be a bit much. Let's just keep it at 100. Okay. So I'm going to just drag this over and let's take a look. So I think it should be sort of obvious that mod position false is going to be more common. You know, how much more common? I don't know. You know, this is like one of those things. Is this a ratio? Uh-oh, I'm asking another question that we can use Python to solve, right? Or to try to approach an answer. But for the moment, let's just analyze this. Let's look at this. So 8 modulo 1, well, sure. 12 modulo 2, 24 modulo 3, 36 modulo 4, 60 modulo 5. Is there anything really about these? Is this occurring in any kind of regular interval, right? 8 to 12, 12 to 24, 24 to 36. Well, you know, those kind of look like, well, they look like multiples of 4 offhand, right? Yeah, that's interesting. So, yeah, this is kind of an interesting pattern. And, you know, I think I'd have to take a lot more time with this to kind of understand what's going on here. But, you know, this growth, maybe we could determine, is this a consistent rate of change, or is this a rate of change that we can effectively define? You know, that I think it might be. I don't know offhand, but I think it might be. Yeah, let's try this for yeah, sorry, I'm just getting curious about this now, and I don't really need to be curious about this at the moment, but yeah, I haven't really thought about this problem until just now, and I'm trying to explain this to myself, and I could probably take more time with this and, you know, really try to explain it, but it's still interesting. You know, it's kind of a fun problem. Let's increase this to 200 and just sort of peek around at it. And what you'll find out in the world is you get some data. Even if, in this case, I'm synthesizing data, right? This is not something that exists. I'm making this up, and I ended up with a number series that I'm not necessarily very capable of determining what if this is a differently definable number series offhand. And I think this is sort of this thing that happens with data. Whether it's synthesized, whether or not you grab a CSV off of Google data sets or something like that, you start picking through it and it just brings up questions, and you realize that you don't understand how it's working. You don't understand what's going on there. And you want to start digging into it and really try to understand. Sometimes, it can be out of your expertise. Like, this is not necessarily in my expertise. I'm not an expert on primes. There might be some very simple explanation that somebody else could look at this and say, oh, well, that's just this. And in data science in general, you want to reference experts. Like you can write an epidemiological model, but you're not an epidemiologist, right? So you would want to consult with them, and you want to work with them to gain insights on things. I did this lacrosse, this modeling of like player detection and point inference and things like that, possession inference from video footage of lacrosse games. And I used YOLO V2 to do this. I don't know anything about lacrosse. And I didn't necessarily learn a lot about it. That's not true. I learned a lot about lacrosse, but not because I ever played it, not because I studied the rules, because I sat there and I analyzed video footage and built a model that could do this kind of real-time detection. And to understand the game, I needed to consult with this person who was really into lacrosse. Like that's just par for the course with a lot of this stuff. Either way, though, you can explore things, and I think looking at this, right, we've got some sort of rate of change. We could plot these things. We could start at 1, and x is 1, y is 8, x is 2, y is 12, x is 3, y is 24, and so on. We could plot this kind of growth, and we could also take the I don't necessarily it's sort of a concept like derivative, but we could look at the changes between these, and we could try to determine a function that will tell us this rate of change. So, this analytic approach of using dictionaries just helps you parse things out in a way that can help it to be understandable. So a question just came in. What are strings from... so what are strings Q3? Let's take a look at that. And I will clear my terminal, and maybe I'll set this aside. There were some questions that occurred to me, but I can swim around in some code for a really long time, and I think it's nice to just answer some questions sometimes. So we're looking at Q3 of this. So I'll take a look at it. Write a function called whitespaceCounter, which should take a single string as an argument and return a count of the number of whitespace characters contained in the string. Cool. So let's try to solve this. Okay. Write a function called whitespaceCounter, which should take a single string as an argument and return a count of the number of whitespace characters contained in the string. All right, so this is going, not mod position false. This is going to be called whitespaceCounter. And we already said it takes a string. Python's nice in a way because you can name a string because the actual data type is str. And we want to return the count of the number of white space characters contained in the string. It turns out this is really easy. You can say return string.count of empty space. So I'm going to grab a random Wikipedia article. Let's say just Wikipedia. And I'm going to get a random article. And of course, it's one sentence long. Oh my gosh. Okay, just give me something with... Fine, yeah, here we go. Let's do this. So I'm going to call this string to check and just paste this in there. Do that. And I'm going to print white space counter of the string to check. And let's see if that works. So it says 65. Is this function good enough? Let's find out. Because, well, let's get out of there. So when we're saying white, it failed. Notice how it failed. So we've got this \n. All right, well, \n is something that we need to account for, right? Because that's a form of a white space character. What else do we need to account for? Well, we can take a look at our tests and we can find out the other forms of white space that we want to consider. So we've got this new line character, right? Which is like hitting enter. We've got tabs. Okay. Is there anything else in here? It kind of looks like those are the only kinds of characters that we need to account for aside from spaces, I believe. So why don't we make our function just a little bit more robust? I'm going to say let's return the count of empty spaces because I'm assuming it still wants that it wants those. And let's return new lines. And let's return tabs. And now if I run this, we'll actually get the same answer here because it's all in one line. But and there are no tabs in there. But let's take a look because the only thing that I'm considering here is that maybe they don't mean empty spaces as white space. Okay, so let's take a look at this. 3 does not equal 6. \t, so 1, 2, 3, 4, 5, 6. Oh, well, it looks like there's other things, right? So we've got this \v, \f, and \r. Okay, well, let's count those too. And I'll just set that there for the moment. Oops. So \v, \f, and \r. So this is really, in determining what white space is, in this case, what we're really looking at is being able to effectively read the errors. Okay, and that worked. So this is a single line where we're just summing the string counts. Let's look at this other way of doing it. Def white space counter of string. We have a counter, right? Symbol accumulator pattern. We say for each character in the string, if the character is space, if it's a space. Well, is space on a character is a method that's going to tell us anytime that this is a white space character, whether it's an empty space, whether it's a new line, whether it's a tab. I honestly don't remember what \v is. But either way, this works. But so does this. And if you want to ask yourself, well, which is preferable, that's fine. I don't have a clear answer to that offhand. I would prefer this, where we just sum each of the characters that we consider to be a white space character. But this is also completely valid, and it has a simple method that makes that determination for you. Yeah, either way works in terms of our test. So let's take a look at what you have here. And yeah, and let's think about this. If the character is empty, just an empty space, or \f or \v, so you're on the right track here. You're just missing \t and \n and \r. So this, you just have to move it a little bit more in that direction. You just have to include a few more potential white space characters. So you were on the right track. At some point, it's really just about reading those error messages. Okay. So I'm going to delete that. There's another question here. While we're looking at strings, can we look at join and split Q2? The code I have seems like it would work, but maybe I'm misreading the question. Def split then join, string delimiter, new delimiter, return string not split. Oh, okay. So let's take a look at this. And this is Q2. All right. I don't know that I've looked at this one yet. Implement the function called split then join according to the doc string. All right. I'm going to go ahead and I'm just going to look at this for a split second. Splits the string on occurrence of delimiter. Result of splitting the string at the given delimiter and then joining with the new delimiter. Oh, okay. Yeah, this is nice. Let's leave this string to check in here, and we'll go ahead and use that. All right, so implement the function called split then join according to its doc string. I'm going to go ahead and copy all of this over to my terminal, over to my code editor, and notice I have a string that I'm going to use to check to see if this works in the way that I would expect. All right, so split then join, we're passing in a string, delimiter, and we're replacing the, so whatever we determine that delimiter to be, we're going to split the string along that, and then the new delimiter is going to replace the old delimiter in the new returned version of the string. Let's think about this one at a time. We pass in the string, and we want to split it on the delimiter. So I'm just going to call this the split string, and this is going to take string dot split, and let's split on the delimiter, and then all we need to do is our join trick. Like all we really need to do here, I believe, is say let's return that split string. And remember, this is a list at this point, and we can say something.join that split string, and what we're going to join on is the new delimiter. Oop. So I believe that should work. And I don't think I'm missing anything. I'm going to go ahead and just for the moment delete this doc string so we can see it all in one place in case I need to troubleshoot anything. I'm going to take that string, right, which I called string to check, just a random thing from Wikipedia, and I'm going to split on spaces, and instead of spaces, my new delimiter is going to be dashes. So let's see if that works. Oh, I should probably print it so that we can see the results. That looks reasonable, right? That looks like we've replaced all the spaces with dashes. Okay, let's see if that works. And then I'm going to show you another way that we might be able to trick this and solve it. Let's see if this works first. It's taking a while to run the tests. I'm not sure about that. Oh, okay, that worked. Now, this is nice. This is a single line solution. Notice that split string here, we don't really need to make its own, we don't need to make a namespace for that. We can just take that and put it directly in there. Okay, so this also would work. There's something that I want to see if it works. Let's just return the string dot replace. Let's try this. Let's replace the delimiter with the new delimiter. Let's see if this also works. It seems like it should logically be the same, but offhand, I don't know if this will pass tests in the same way on this problem. Oh, it doesn't. It doesn't. Interesting. Okay, why is that? Because delimiter is not defined. Well, okay. Delimiter. We actually want this to be delimiter. So let's try that again. And that worked as well. Okay. So notice there are two distinct ways that we can solve this. We can solve it with, doing this new delimiter.join string.split of the delimiter. That works. But honestly, we're just replacing the delimiter, aren't we? So we could just use the replace method instead. Awesome. Let me know if there's anything confusing about that. Outstanding. And it looks like I'm just going to take a look at your code. Let me see what you have here that's distinct from that. Okay. String.split delimiter. Oh, I see. You know what? I don't know that I do see what's going on here. I'm just going to try to adapt yours to, so you shouldn't need this string cast. Although that may be part of the issue. So delimiter here is, it doesn't need to be in quotes because it's its own variable name. New delimiter also doesn't need to be in quotes. Yeah, you're just sort of not using join correctly here. So join is weird. Join is a method of a string, right? So you have some string, right? Often an empty string, and you're going to join. You're going to join some things in a list, right? Cat, dog, mouse. And this will give you output that looks something like, well, it looks exactly like this. It'll be cat, dog, mouse, right? If you add a delimiter here, like a space, then that's going to change that by doing something like that. If you put in a plus sign, then you're going to get plus signs in here, right? So that I think it's just join. It looks weird. Like this join structure is a little confusing at first because it doesn't look like very many things in Python. It's its own, like stylistically, it doesn't look like very many other things, and so it kind of makes sense. Well, it makes sense that you would think about it this way, right? You're joining on the new delimiter, right? Like you're splitting on the old delimiter and joining on the new delimiter. But this is actually like just you have it inverted because the new delimiter is the string, and then you take this method of that string and you interpolate the new delimiter into, right? You interpolate this new delimiter into the string in between each of these string items from the list. Yeah, it's a little funny looking, but once you do it a few times, it's almost like, you know, I often will tell people to memorize this structure, the structure that looks like this, something.join of a list. You know, and that list is going, every item of that list is going to get joined with whatever is in between these quotes, right? Something to watch out for here, this is just a side note. If you have, and maybe I'll just do this. So why don't I make, I'll make this a string. I'll just call it string, and then instead of all this, I'll print string. So let's say we have a list, and in that list are some numbers. This is just something to watch out for. So let's say we want to join all those numbers. You know, we're making the string, we want to join where we have dashes in between all the numbers. So it'll be like 1-2-3, all is one string. So look at what happens when I run this. It says sequence item 0 expected a string instance int found. So these being strings makes it so that we can't actually we can't run join. Like this has to be a list of strings. So how do I make this a list of strings? Well, it might occur to me to do this. You know, list gets string of list. However, that doesn't really work. It's sort of strange. Like, okay, well, this is not what we expected over here. This let me run that again, just so we can see it a little better. We get this thing, and in between every string character, we've interpolated a dash. So this was a string character. We put a dash, then we put 1 and a dash. So this doesn't really work how we'd expect it to. And actually what we would need to do is convert every one of these individual items into a list. Turns out that this, on line 23, this is not a list. This is a string that looks like a list. And so the way I usually do this, I'll do this the kind of the way I do it, and then I'll show another way to do it. I would say string of each item in string of each item for each item in the list. So I'm going to stringify each item. And if I do this now, we should see what we'd expect, which is this 1-2-3-F4-5. I can translate this. I can say, well, let's call this list of nums. I can do this with also with an accumulator pattern, right? Where I say list is an empty list, and I say for num in list nums. Oops. In list nums, I can say list.append the string of that num. And so this should also work for me. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's fine. So hope that is illuminating. Okay, back to. Oh, I was gonna call it half an hour early today, and we're right about that time. I'm gonna take this kind of obtuse problem that I was exploring with the modded positional values of the twin prime sums. I don't know. I think it's interesting. It's always interesting to see what numbers do. I'm gonna go ahead and paste this in to the Slack, and I hope you all have a great holiday weekend. I think I will stream on Monday, just for fun, just because I think, it's the last time I'm going to be able to stream before the interview cutoff, and I think, I can go over some dictionary stuff, TI stuff, whatever questions you have. So I might do that Monday. I'll announce if I'm not. It is a holiday, so I might just take it off and hang out with friends and everything. But yeah, I hope all of you have a great weekend. If you're studying up for your TI and you're not taking a break, good on you. If you are taking a break, good on you. We're coming down to the deadline for October's technical interview. So if you're trying to make that deadline, make sure you book your interview, and so that we can fit you in before the cutoff. Talk to your enrollment advisor, and happy studying. So here, I'll just paste in my code if you want to play around with it. And I'm going to continue to encourage you to be inventive and ask silly questions and try to answer them for yourselves using Python. This is the phase for that, and you've got some time for that, and that's how you really build your strengths in Python, is you do the invention. We're giving you a lot of problems to do, but when you start giving yourself your own problems, your learning in the language just expands. So all right, enjoy your weekend, everybody, and I will post something Monday if I'm not going to stream. Otherwise, I'll see a number of you on Monday.